Right. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. So my name is Majikir Rivaludin and I'm from mechanical engineer. And here I'm gonna present my final exam numerical method 03. So the first thing we must do is muhasabah. So Bismillahirrahmanirrahim, in the name of Allah. First of all, we must be grateful because we are able to complete the given test. So I will say practically address each part of question using appropriate formulas and principle of day 5. Conscious thinking using the day 5, which is include initial thinking, intention, negotiation, and instruction set. I reflect myself during the learning of numerical method course. I always enter the numerical method course class in the timely manner. I also gain a lot of understanding in this course, especially in conscious thinking learning. I also took a tutorial class held by an assistant lecturer, although I was sometimes a bit confused in working on some materials. But I didn't give up and I always tried to try again by reflecting on myself and trying to do it in calm and sincere state. I also made a video review of every lesson that has been done in class. By making video, I can see my in the past, and I can remember the material that has been taught. I took on additional responsibilities this year, like including specific assignment or process. I managed to blend this new text with my current workload. I use this feedback to make improve when is areas such as communication, teamwork, and time management. I managed to overcome several challenging situations this year, including problems in my daily life using understanding of the AI5. I remain calm, focused, and professional under pressure. I demonstrate strong time management skills and using my time effectively and efficiently to complete my work on schedule. I constantly are excited explanation for guidance and punctually with my own self-assessment at 85. So the number one question is like this. The theory application of spring mass system, like the A is determine the critical dam value for each shock, and the B is solve the spring mass system for each shock with the given damping, and also with the critically damped value. And the C is discuss the model each shock. So the number one is intention, of course. The STT or the satellite transportable terminal is loaded with a satellite and suspension system must absorb shock to protect the satellite during transport. So the goal is to ensure that the STTs are reliable and protect while being loaded and transport, especially under harsh condition. And the initial thinking is the CC trailer is loaded with satellite and the suspension system must absorb shock to protect the satellite during transport. So from the data, we can get the mass of from data, we can get the mass, displacement, spring, damping coefficient, spring constant, damping coefficient, spring constant, and the damping coefficient too. So what we need to find is number one is critical damp value. Number two is solve the spring mass value. So number three is compare the shock. So here's the illustration. The illustration is the A is the critical damp value of the damping coefficient for a spring mass system is determined by the formula BC 2km with the no spring constant and damping coefficient difference equation like this M2 dx per dt 2 P dx per dt tambah kx tambah f T determined by the roots of the characteristic equation MP per tambah bx tambah k. We can solve the problem using Python and determine which shock is the best for the SAT suspension system following and explanation the reasoning. So instruction set is the A is air coaster, that we can get the BC is 128,30 ns per m, and K is 220 n per m, and the M is 1800 kg. Cloud riders we can get is 651,82 ns per m, and extreme shock is 1007,26 ns per m. Number B is using Python gating. So we can get like this, calculator shown in the last page. And last, we're gonna show the algorithm. So the say is a coaster, and the dam will escalate before setting down. Good for system when where quick response is needed, but population might be a concern. So the two is called riders over dam. Returns to equilibrium slowly without oscillation, very slow response, which might not be ideal for dynamic application. Number three is extreme shock. Luckily, for them similar to critical damping, is zero smooth and quick return to equilibrium without oscillating. So the best choice for that is considering the application for military satellite transport table terminal is the suspension system should prioritize stability and quick settling without oscillation. So the cluster is too much oscillation that's with given damping. It is not good. Providers it over damp and slow response with a given damping. Extreme shock is close to critical damping, provides a balanced response with a quick starting and no collision. So, which means the recommendation is the extreme shock. So this is the code for Python, and this is the graphic, and we can get the graphic is so the key element in the plot. This was an M. The y-axis represent the displacement of suspension system in meters. The time is S is the x-axis represents the time in second, lines representing different secondaries. Each line corresponding to a specific scenario with different shock type and damping condition. There are three types of shock: air coaster, float riders, and extreme shock. Each shock is type is analyzed to under two damping conditions, even damping and critical damping. So here's the number two question. So the intention for number two is so number two, the intention is to determine the proper shock absorbers suspension system of the SAT satellite transportable terminal that will avoid damage to the satellite during transportation over served terrain. And the initial thinking, like we can solve the non-homogeneous and find the compare the maximum and minimum, identify and analyze the transient and steady state. So the utilization is simplifying assumption that assume the system is initially at rest. FT sebelum bertusin AT and represent the most of terrain condition at the highest speed of an image with trailer. So the instruction set we can see in here that first of all, of course, we need to solve this equation and plot the solution. To solve, we can get the force, we can get the differential equation and Python coding. Number B is to find a maximum and minimum displacement for each shock that we can use the Python tool like coding. And the C is to determine the best shock. So the air coaster and both riders might be slow to respond, but the air coaster is potentially to collision. The best is extreme shock due to engineer critical damping provides stability and quick response. The transient solution also quickly miss allowing the steady state solution to determine. So this is the code and this is the graphic analytic. So for the graphic, the plot highlights how different shell shock impact the suspension. system dispersion over time, and Eric Forster does the largest equation, inducing a more surf shock while cloud riders in extreme shock result in more moderate displacement. Understanding the response is crucial for designing suspension systems that can effectively mitigate the impact of various shock and maintain stability. So here's the question of number 3. All right. So number 3 intention is the goal is like we can see this is to solve an intentional valve problem involving a spring mass system with given specification for the suspension system of the STI. So the initial thinking is number 1, we can solving the differential equation for the system. Number 2, identify a specific condition under which the solution is invalid. Number 3 is creating an interactive part of the social solution over a specific time frame and discussing potential damage interaction. So the forcing function is given as ft sin, and we need to solve the system with 25 nm and b beta is 0 ns per m. So here's the visualization for number 3. So the visualization that we can get the differential equation promoting for an undepth system. So number 1 is the system is under depth beta 0 and the spring constant K is 25 n per m. The mass is 1,800 kilogram, and external force is that we have to sin, and initial condition is 0 and the x is 0 2. So the instruction that we can get is the formula, the homogeneous solution is mx plus 2rx sama dengan 0. So the general solution that we can get is xn t, and the particular solution for the non-homogeneous equation we can get is xp sama dengan a sin. We get the value of xp like this, and we can get the xt is minus 25 per 16 m. Since w quadrat must be positive, no real positive value for we makes the solution invalid. However, if we cause resonance, the system and world experience unbounded growth in amplitude. So the part C is using Python that we can see where that I can show the next page and discuss potential damage due to large amplitudes. The recommendation is the budget commit should avoid undamped shock and invest in partially damped shocks like the extreme shock to ensure the safety and integrity of the satellite during transport. So this is the code, and this is the graphic analysis that we can get two graphic analytic actually. Like the graphic one is shown displacement over time for extreme shock, like non-homogeneous like that is moving. Otherwise, the homogeneous is not is steady state. And the second graphic is displacement of spring mass system for various frequencies that we can get smart like 0.5 rad, 1.0 rad, and 1.25 rad, 1.5 rad, and 2.0 rad. So this is number 4 question. Right, the number 4 is the intention. The 9091 is the model the vertical motion of the excited travel caused by the firing of a heretical defender event MIP high powered and machine gun. By analyzing the data, estimate the damping coefficient, we aim to understand the trailer behavior and determine if the system will stabilize or if structural intensity will be composite. So the initial thinking that we can get is number 1 is plot the displacement data, Number two is use data to estimate the damping coefficient by minimalizing. Number three is the evolution of system is expressing resonance by or bits. Number four is determine if the trailer structural integrity will compromise if the system continues to operate without turning off. So here's the relation that we can get the mass is 4,000 kilogram and the spring constant is 5,000 N per M. And the damping coefficient is to be estimated. We can search the damping coefficient and the external force that we can get is 300 cos Kn, and the initial condition we can get is 0 and 0, 2. So the instruction set number one is plot the data, two is estimate the damping coefficient, and the three is evaluate resonance or bits, and four is access structural integrity. So the solution that we can get is plot the data using a Python and estimate the damping coefficient, and the C is to determine itu kita bisa menggunakan rumus WN sama dengan K per M that we can get is 1.118. So this we need to determine if the displacement except 0 meter. We solve the equation over a long period to check for maximum displacement. So this is the code, and this is the graphic analytic. So the graphic analytic that we can get is displacement of the trailer with gun firing. So the displacement is moved up and down, and the time is from 0 till 60. You can get the graphic like this. So the number 5 question is like this. So number 5 intention is to analyze the performance of shock system and determine whether the structural integrity of the truck will withstand the truck terrain. The initial thinking is the extreme shock with spring constant U 117 N per M and damping coefficient P is 110 NVM were chosen as the best option for prevent damage to the satellites while being loaded and transported. So number 5 illustration is to model the suspension system of a spring mass system with a spring constant K, and B, the extreme force applied to the suspension system is modeled as series of impulse function. So here's the instruction set that we can get the spring and the differential. We can use the XS and we can get this number verifying using to determine using mathematical input. And the B is maximum and minimum displacement. To find the maximum, we need to analyze the solution obtained from the Laplace transform, and the C structural integrity and regulation. The maximum allowable displacement is 20 cm or 0.2 meter. And the guidance, if the displacement exceeds 20 cm with 3 seconds, it suggests that the system is already at rest. Reducing 2 seconds likely accelerate this issue, making it unsafe for the structural integrity of the SAT. And the guidance is from the analysis if the displacement exceeds the 20 cm limit, it is advised to either reduce the speed of route train or increase the damping coefficient to prevent structural damage. And here's the code for number 5. And this is the graphic analytic. So that we can get is displacement of SCC trailer over huge train that we can see in the 0 like is up until 5 seconds of second at displacement 3.5 meters. It's go down till 20 seconds. That displacement get 0.25, I think, and it's steady state until 60 seconds. So the last question is the Elon Musk question. So Elon Musk statement that our extensions may be just simulation raises deep question about philosophy and epistemology. So, in my opinion, this is concept in line with a special branch of philosophy, which propose that what we think as reality can actually happen in our daily life. It's just how we respond to it. If we really think that the technology can threaten our life, then we will think that the technology must have its limits. And if we respond to with the thought that technology can bring very good benefits to humans without seeing the bad side, why then humans is better than AGI in the future? So, in my opinion, is humans are remarkable ability to think creatively, generate novel ideas, and innovate in ways that may be difficult for AGI to replicate. This is this creative process often involves intuition, emotion, and experience that are invaluable of human. Human can adapt to a wide range of unpredictable, novel situations. This adaptability system from our ability to learn from experience and apply intuitions and improve in real time. Humans experience consciousness and self-awareness, allowing them to reflect on their thought, actions, and existence. This is introspective ability is a proud aspect of human life that AGA lacks to. I mean, it's the way we think that AGA is good or it is bad, that the way to think and I think and the AGA is the creative process often involved. So that's it for my presentation. So this is the pray for we're grateful of Allah Subhanahu wa Ta'ala. Alhamdulillahillazi ja'ala fil amri so'atan. Segala puji bagi Allah yang memberikan keleluasaan dalam masalah ini. Thank you once again. Thank you for Mr. Dai that give us so many things that I can get from the uh, lecture. So that's it for today. Wassalamualaikum warahmatullahi wabarakatuh.